Welcome to this tutorial on binary trees. In this video, we'll be discussing what binary trees are and different types of binary trees. A binary tree is a tree data structure in which each node has at most two children. Here is an example of binary tree. In this tree, the root node is 5 and has two children, 3 and 8. The node 3 has two children, 2 and 4. The node 8 has one child, 6. Looking into the diagram, it satisfies the condition given for a binary tree where each node has at most two children. Now, if you have a binary tree, the maximum number of nodes on a level I is given as 2 to the power I minus 1, where I is greater than or equal to 1. So, in this diagram, in the tree structure given here, let us consider the levels. The root node 5 is at level 1. The nodes 3 and 8 are at level 2. The leaf nodes 2, 4, 6, 9 are at level 3. So to calculate the number of nodes, the maximum number of nodes at a particular level I, let us consider the level as 2. So at level 2, that is at when I equal to 2, the maximum number of nodes of a binary tree is given as 2 to the power 2 minus 1, that is 2 to the power 1, which is equal to 2. At level 3, that is at when I equal to 3, we will see that maximum number of nodes at that particular level in a binary tree can be 2 to the power 3 minus 1, which is equal to 2 to the power 2 and equal to 4. Now, maximum number of nodes in a binary tree of level k is given as 2 to the power k minus 1, where k is greater than or equal to 1. So, in this particular example given here, we will see that this is a binary tree of level 3. Maximum level is 3. So, at a binary tree of level 3 will have maximum number of nodes as 2 to the power 3 minus 1, which is equal to 8, minus 1, which is equal to 7. Now, there are different types of binary tree and few of them are listed here. Full binary tree, complete binary tree, perfect binary tree, balanced binary tree, and binary search tree. Let us discuss about full binary tree. A full binary tree is a binary tree in which every node has either 0 or 2 children. You can see two examples here. Notice that in both the trees, the nodes have either 0 or 2 nodes. In the first case, we will see the root node has 2 children. The intermediate node 3 has 2 children, 2 and 4, and the intermediate node 8 has 2 children, 6 and 9. Whereas in the second example, we can see the root node 1 has 2 children, 2 and 3. The intermediate node 2 has 2 children, 4 and 5, and the node 3 has 0 children. Both of the example given here goes with the definition which says that every node has either 0 or 2 children. Now looking into a complete binary tree. A complete binary tree is a binary tree in which all the levels are completely filled except possibly the last level, and the last level has all the keys as left as possible. So if you look into this tree, all the levels except the last level are completely filled. And look into the last level, that is the node 1 is filled from left to right. So a complete binary tree is a binary tree wherein till the last but one level, the tree should be completely filled, and in the last level, it should be filled from left to right. Next one is a perfect binary tree. A perfect binary tree is a binary tree in which all the internal nodes have two children and all the leaf nodes are at the same level. Now, if you look into this example, you can see that all the internal nodes, that is node 5 has two children, 3 and 8, 3 has two children, 2 and 4, 8 has two children, 6 and 9. And look at the leaf node, 2, 4 and 6 and 9 are the leaf nodes, and all the leaf nodes are at the same level. If you look at the second example, node 6 has two children, 3 and 2, 3 has two children, 7 and 8, 2 has two children, 6 and 4, and the leaf nodes 7, 8, 6, 4 are at the same level. Next is a full binary tree that is not perfect binary tree. So in this case, we see that, let us recall what is a full binary tree. So we saw a full binary tree is a tree wherein every node in the tree has either a 0 or 2 children. So if you look into this example, this particular tree given here, every node has either 0 or 2 children. 1 has 2 children, 2 has 2 children, 4 and 5, 3 has 0 children. So this is a full binary tree. But if you look at the definition of perfect binary tree says that all the internal nodes should have 2 children and all the leaf nodes should be at the same level. Now, internal nodes. Node 1 has 2 children, 2 and 3. 2 has 2 children, 4 and 5. Now, look at the leaf nodes. Leaf nodes are 4, 5 and 3. We see that 4 and 5 are at level 3, whereas 3 is at level 1. So hence we can say that this is not a perfect binary tree. So don't get confused between full binary tree and a perfect binary tree. All the perfect binary trees are full binary tree. But a full binary tree here, what is given here, need not be a perfect binary tree. So a full binary tree that is not a perfect binary tree is the one where not all the leaf nodes are at the same level. Next is a balanced binary tree. A balanced binary tree is a binary tree in which the height of the two subtrees of any node differs by at most 1. Here is an example of a balanced binary tree. In this tree, the height of the left subtree, that is 3, 2, 1, is 2. And the height of the right subtree, that is 9, 8, is 1. The difference in height between the two subtrees is at most 1, which satisfies the definition of a balanced binary tree. Next is a binary search tree. This is a binary tree in which each node has a value and the values of the left subtree of a node are less than the value of the node, and the values of the right subtree are greater than the value of the node. Here is an example given. In this tree, the root node is 8. The value of the left subtree is 316, which is less than the value of the node 8. And the value of the right subtree is 109, again, which is greater than the value of the node 8. This makes it the binary search tree.